also a doctorate from Stanford in electrical engineering. But key to this conversation today, all of that included, of course, is his 7 years experience at Yahoo, running VP Product Intelligence Engineering. And as we all know, Yahoo was probably one of the first organizations, much like Jeff's at Facebook, to leverage an enterprise implementation of Hadoop for enterprise mission-critical analytics. And I think there were a lot of obstacles, a lot of pitfalls, a lot of great opportunity came out of it, and Amr was right in the middle of that. And so I think his discussion today will talk to a lot of those aspects and maybe help you avoid and find some of the nuggets of gold that he found in his efforts. So without further ado, I'll turn the stage over to Amr.
Thank you.
Thank you.
I think I'm going to stand down here so I can point to the slides. Is the mic working? Can everybody see me fine? Good. Cool. So I'm going to tell you more about the history, about how I personally came across Hadoop in the same timeline that Jeff Hammerbacher also came across it, but within the lens of business intelligence from my point of view. So I'm sorry if you were here only to hear about data science. This next section is going to be more about business intelligence. So before I dive into that, though, Jeff asked the question, how many data scientists out here, and we only saw a couple of hands go up. So I want to try and get more hands to go up. So first I'm going to ask, how many of you here in the audience heard of the word Hadoop before today? Okay, that's very good. That's about, I would say, 90%. How many of you heard about Cloudera before today? Very good as well. Now the next question is, how many of you would classify yourself as a statistician/quant? So that's about maybe 30%. How many of you would classify yourself as a business analyst, to use some sort of BI tool to look at data and make decisions? About 20%. How many of you are in IT? Your job is to deploy databases, deploy ETL tools, BI tools, etc., etc. That's about another 15%. Cool. Any other major categories I forgot that somebody, I don't want to, did somebody not raise their hand and they're sad I didn't pull out on them?
1 and 2, a combination of 1 and 2.
A combination, so between 1 and 2, okay, good. So essentially as Steve said, I was at Yahoo for almost 8.5 years, though within the BI track within Yahoo, I've been on that for about 6-7 years. And this is my story of why I moved towards Hadoop and what forced me to move towards Hadoop, and why I couldn't do things the old way and I needed a new way. So this is what the business intelligence and data processing stack looks like in any organization. You all have something that looks very similar to this. You start at this layer here where you instrument the points where data is being generated, where data is being born. And that could be web servers, could be application servers, could be network equipment, mobile devices, syslogs, etc., etc. So you instrument the points where data are being created. You collect the data, and then typically you store all of that data in a storage-only grid. In a storage grid that knows how to store data, but that's all it knows what to do. It doesn't know how to query data. It doesn't know how to process data. It just knows how to store data. So the next thing, because you want to ask questions out of that data, what you do is you typically go through this process called the ETL process, extract the unstructured data, transform it from unstructured to structured, and then load it inside a relational database management system like Oracle, Teradata, etc., etc. Oh, I think my mic is better on the other side. Let me do that really quickly.
ETL.
And once you have the data inside the relational database management system, then you're able to run interactive applications and BI tools like MicroStrategy, like Tableau, like Cognos, Business Objects, etc., on top of this data and ask the questions that you wanted to ask, because you couldn't ask them down here. This is the traditional business intelligence data stack in any organization. To be more specific, at Yahoo, in my organization, for For this layer here, we used the NetApp. We have lots of NetApp storage here. For this layer here, we had a combination of some custom compute grid stuff we built, lots of Perl scripts actually. And then on top of that, we had IBM Data Stage for doing the second stage of ETL. For this layer, we had one of the largest Oracle rack installations in the world. It's got 16 Oracle servers. Each one had 16 cores, lots of memory, lots of disk. And up here, we had MicroStrategy. So that was kind of our stack at Yahoo. We had these three problems, and you have these problems as well. If you didn't have them yet, all of them, you have one of them, and soon you have the other ones. So what are these problems? The first problem is this one, is moving, as data gets bigger, as we start to get more sophisticated in collecting information, this structure of having storage on one side, having computation on the other side, will not scale with you. It will not scale. The network in the middle will become a bottleneck. That's a fact. You can't avoid that. So, specifically, in my experience at Yahoo, we had an ETL window, meaning we had to finish transforming all of the data from the previous day into our models before 9 a.m. the next day. So literally, we had 9 hours to finish transforming everything. And we were about 7 hours. And it was clearly going to hit the window, which means we would never catch up. Even worse, if we made a mistake in our ETL, meaning we had some wrong business logic for the transformation, and we had to go back and reprocess the last 3 months to fix that mistake, forget about it. We couldn't do it. Because the network in the middle here would not scale. Having my compute grid separate from my data would not scale. We needed something new. So that was number one, scaling our ETL. And that's the most common use case for Hadoop today. The most common use case in our installed customer base today is about that. How can I make my ETL pipeline more efficient and more scalable economically? Of course, I can go on and buy way more highly provisioned networks, way more expensive storage, and way more expensive computation and achieve my deadlines, but I want to achieve it economically. And I'll talk more about that later on. So that was number one. Number two is we had lots and lots of data down here. And this data had lots of value in it. But we couldn't extract that value because this layer is only a storage-only grid. It couldn't compute. So what we would end up doing is we would impose retention windows where we would say, only keep that data for 6 months or a month, and then move it to archive, move it to tape. And as you all know, once data goes to tape, you don't see it again. Tape is the data graveyard. It takes an act of God or government to bring data back. God meaning disaster recovery. We have a tornado somewhere and needs to bring back data from another data center, from tape backup, and government meaning you're being subpoenaed on something, right? And the reason why is because tape is extremely cheap for storage. That is true. However, it's extremely expensive for retrieval. To get stuff back from tape to be able to process is a very expensive proposition. So we need to solve that problem. We need to have an ability to keep data alive much longer. And that's what Jeff referred to earlier as the active archive use case, which is the second most popular use case within our customer base. Now the third use case, and this one is the most advanced, this is the data science use case, right? So in terms of the hierarchy of needs or the hierarchy of adopting this platform, you first want to make your SLAs for doing what you're doing today better. You second want to be able to keep your data alive for longer so you can extract value from it for longer periods of time. And then third is now you want to start looking at your data in new ways and ask new questions out of your data. Because the data that you were able to move into here is only a subset of this data. This is the original high-fidelity, raw, unstructured data as it was collected. It's a natural byproduct of the ETL canonicalization process, is that you will get information loss. The information you will have here will not be as high fidelity as this information. The information you will have here will be only the information you need to answer the questions that you knew ahead of time, what we call the unknown knowns. But there is so many questions that you did not know ahead of time, for which the answer is still down here, but you couldn't access it, right? You couldn't access it because this layer is a storage-only layer. that's the data exploration, data science use case. So we had these three problems. We had the existing infrastructure. We were struggling. We couldn't solve them. We needed something new. We looked at the existing technologies in the market from the relational database space, from the virtualization space, the high-performance computing space, the storage space, et cetera, and none of them could address this. We were lucky that at the same time that we were starting to encounter this problem, this other technology called Hadoop was being born. It was being born for another reason, and I'll talk about that later on. It was being born for search and how to build search indexes for the web. However, we very quickly, myself at Yahoo, Jeff at Facebook, saw that this technology can solve these problems as well. So this is the before and after picture. And I'll toggle between them for a second there so you can see the difference between them. But essentially the difference is all the X's go away, all the big red things go away. All the problems are solved. So essentially the solution is to have this layer now, which is a storage plus compute bit. Let's not have a layer which is just storage on one side, and have another layer which is just computation on the other side. We have now commodity hardware that has multi-cores and multi-disk spindles on it. Let's leverage that to provide a layer that can hit both birds, my storage needs and my computation needs at the same time, and leverage local disk without going on the network as much as we can. And by adopting this solution, we were able to solve all three problems. We now were able to hit our SLAs, ETL performance, things that took us 9 hours for a fraction of the investment, actually. We're taking now half an hour, 9 hours to half an hour. And we see that in our customer base over and over again, when we go against existing ETL implementations, and once they move on top of this infrastructure, they're able to bring down their times by an order of magnitude for a fraction of the investment. Number two, we're now giving you a way to keep your data alive for much longer, so you can continue to extract business value from it. And number three, we open up the highest level, which is the data science, to go in and start ask questions about the unknown unknowns, not just the known unknowns. So you all know Hadoop. You all know it's an elephant. Everybody raised his hand and her hand. The elephant comes from the creator of Hadoop. I'm sorry if you've heard the story already. Doug Cutting, who also was with me at Yahoo and is now at Cloudera. He is the creator of Hadoop. He's the creator of this technology. Back then, 7, 8 years ago, his 3-year-old son had a plush elephant toy, and out of the blue, one day, he literally made up the word Hadoop. The son, a 3-year-old boy, made up the word Hadoop. His dad picked up that word as the name of the project. His son today is 11 years old, and he's very proud of this contribution to the technology space. But what Hadoop really is a scalable, fault-tolerant distributed system for storage and processing. Another very simple way to think about this and to explain it to people is to think about what is an operating system. What is Android? What is Mac OS? What's Windows? What's Linux? An operating system at its heart is two things: store files and run applications on top of these files. That's what an operating system does. Even if you go back to DOS from a number of decades back ago, that's what DOS did.